It may be hard to see what this has to do with tiny samples of iron, or what this has to do with this Saskatoon-based scientist's mathematical calculations.
It doesn't get any more exciting than this.
But rockets, aircraft, in fact many things that may surprise you, have a lot to do with the Canadian Light Source synchrotron at the University of Saskatchewan in Saskatoon. Just ask Jeff Cutler.
We're doing everything from looking at environmental samples to try to look at things for advanced spacecraft development to making better coatings for pop cans. There's something new every day.
Jeff Cutler is a chemist who helps develop business opportunities for the Canadian Light Source synchrotron, the country's most powerful new research tool.
So everywhere there's a bending magnet, we can put a beamline on.
It's why, when he's not doing his own scientific research, you'll often see him leading tours for companies like IPSCO.
If people are trying to probe metals, this is where you could do things like look at stresses and strains potentially down the road.
You just won't find anyone more eager than Jeff to show industry how the synchrotron can help them.
So like I said, there's a real potential opportunity here for anybody to come in and do kind of new cutting edge research.
If Jeff sounds keen, it's because when it comes to working at the synchrotron, he is.
I call it the coolest science job in Canada. Because there is so many different things always happening here and so many different people to interact with. Because science is fun and cool and you get to do things. Where else can I take $1 million of equipment apart and no one gets mad at me?
The CLS synchrotron is one of the biggest scientific projects in Canadian history. What this $174 million facility does is run electrons around what looks a bit like an enormous racetrack. And as they speed along inside that track, they give off intense beams of light that scientists can use to see deeply into materials of every kind. Like the tiny iron samples Jeff Cutler has got inside the beam today. They're from the U.S. Air Force, and what's revealed by shining synchrotron light onto them may just be key to keeping rockets and satellites safe in space.
If you look at why most satellites fail today is because lubricants in them fail, because you don't think about this, but there's a number of spinning parts inside a satellite. Well, if for some reason a lubricant in one of those devices fails, instead of having a $1 billion communication satellite, now you got a $1 billion piece of space junk.
To help prevent that, Jeff is testing iron coatings that could act as lubricants. Helping him do it are student assistant Jennifer Paulson and beamline scientist Ian Coulthard. And as the beam hits the iron samples, data is generated almost immediately.
Hey, is that my peaks? Woohoo!
Yeah. My spectrum?
All right.
Now, while it may look like just a line to the untrained eye, to Jeff and his team, these are important results which will take some time to analyze.
There's a lot of stuff there. I can tell me potentially a lot of stuff.
One of the unique things about a synchrotron is that there can be so many different experiments running at the same time. The Canadian Light Source will ultimately have 25 to 30 beamline stations all going 24 hours a day. So while Jeff and his team study coatings for spacecraft parts at one station, other researchers may be studying cancer at another. It all makes for important collaborations and many a visiting scientist.
Dr. Neville, how are you, sir?
Like this group from the University of New Brunswick.
I was talking to somebody at work and said, "You're going to Saskatoon again? Didn't you just come back from Saskatoon?" I said,
Bumping into people with very different backgrounds is a great way to spark new scientific ideas. In fact, you just never know who may come up with a new research project.
Pleasure meeting you, sir.
Jeff Cutler talked with Prince Philip when he visited the Canadian Light Source in the spring of 2005, and the prince asked some very insightful questions.
And he started saying, well, can you look at the nature of old arsenic insecticides in the soils and how they maybe impact root vegetables, like would they be getting into the potatoes and the turnips and things like that? And I was thinking to myself, that's kind of neat, there's actually a, potentially an interesting experiment there.
And if Jeff decides to pursue the idea?
I may have to put him down as an author in the paper, Jeff Cutler and His Royal Highness Prince Philip.
It seems Jeff Cutler has just what it takes to steer all kinds of people and all kinds of cutting-edge research projects to the Canadian Light Source synchrotron in Saskatoon.
My biggest dream is to have a whole pile of users coming in here being very successful, that somebody gets a Nobel Prize, and the reason they got the Nobel Prize is because they had access to the Canadian Light Source. That would be, the ultimate kind of thumbs up.
So for Jeff Cutler, there's no question. For the Canadian Light Source, the sky's the limit.
No shortage of ideas. Limitless as your imagination is. Get that brain thinking.
For Research News at the University of Saskatchewan, I'm Jennifer Weber.